This video is to move on from where we left off on the last video, where we were taking functions and their inverses, composing them with each other, either f of f inverse of x or f inverse of f of x, and seeing what happens when the original function wasn't necessarily one-to-one. So the answers that we got on the last one is the square root of -3 squared, that was 3. The tangent of arctangent of -1 was -1. The arctangent of tangent of -pi3/3 was -pi/3. And finally, the arctangent of tangent of 2π/3 we found was also -pi/3. So we're going to continue on with these three. This first one, the arctan of tangent of pi/7, I've created a circle where that upper hemisphere, the pi radians, broke up into 7 equal pieces. So 1 pi/7 is right there. So I have a sense of what this is. This is just the slope of this line here. So I go, all right, so let me call that m for the moment. And we're trying to figure out the arctan of that number, whatever it is. It looks, I don't know, kind of small. It's definitely less than 1. It's positive, things like that. But when I think about what this arctan of m is, that's an angle. And this angle has 2 properties. First property is that the tangent of theta is equal to m. Same thing that the tangent of pi/7 happens to be, because that's what we define m as the slope of that line. But the other property is this theta is between -pi/2 and pi/2. Wait a minute, pi/7 is the only angle between -pi/2 and pi/2 that has that slope m, whatever it is. I don't need to know what it is to know that pi/7 is the angle that we're looking for here. So the next one, arctan of tangent of 5 pi/7. I'm going to do the same kind of thing at first. I'm going to go, all right, this is some slope. Well, let me see where that is. And here's 1 pi/7, 2, 3, 4, 5 pi/7. And so we're talking about the slope of that line is what I'm now calling m. And so we're looking for the arctangent of that number, which is some angle theta. And 2 properties about theta. Property 1 is that tangent of theta is this thing that we called m, which happens to be the slope of this line. It's the tangent of 5 pi/7. But the other thing is that theta is between -pi/2 and pi/2. So it can't be 5 pi/7. 5 pi/7's over here, beyond pi/2. It's got to be this guy, which is, well, what is that? That's pi less than 5 pi/7, or another way to say that, it's 5 pi/7 minus a half circle. It's 5 pi/7 minus pi, which is the same as 7 pi/7. So 5 pi/7 minus 7 pi/7 is minus 2 pi/7. And so that's the angle we're looking for. It has the same slope as 5 pi/7 slope is, and it's in the right range. So the final one I'm going to look at for this series is the arcsine of the sine of 2. And so, I start looking at that and I go, okay, so I need the sine of 2. Let me start with the sine of 2. So I'm looking for what we've got, so 2, 2 is about, let's see, 1 radian is here, another radian is about, pi over 2 is approximately 1.5, so maybe there. And so I don't really know what sine of 2 actually is, but now I'm going to think about, okay, so whatever the heck that is, that's the y-coordinate right there. So the y-coordinate right there, it's kind of big-ish, and so I don't know what to call this. Maybe let me call that y, because it's some y-coordinate. So now we're looking for the arcsine of y. And so the arcsine of y is some angle, and that angle is the angle that when I take the sine of it, I get y. And the other thing about that is it's between negative pi halves and pi halves. So let me think about that. Okay, it has the same y-coordinate, because y is sine of 2. So it has the same y-coordinate as 2 does, but it's not 2, because 2 is beyond pi over 2. We just talked about that. So similar to what we just did on the last problem, it's got to be down here with exactly the same y-coordinate. Can't be over there. Can't be over there. Why can't it be over there? Take a minute to think about that. Hopefully you thought of it. Wait a minute, the y-coordinate's negative over there. So I'm looking for something between negative pi halves and pi halves that has exactly the same y-coordinate. It's actually over here. So I have to think about what's the relationship between 2 and this other spot right there. So I'm gonna draw that bigger. So here's this unit circle. Here's 2 radians getting you to there. Here's this other spot with exactly the same y-coordinate. So the y-coordinate here is the sine of 2, but the y-coordinate here is also the sine of 2. And we're trying to figure out what's that angle. And if I think about it, this little reference angle right there is the same as this little reference angle right here. So maybe let me call it a reference angle. So 2 is just pi halves plus this little reference angle. And this angle that we're looking for, this guy, because remember, this arcsine of sine of 2 is this angle, That's the arcsine of the sine of 2. And so what we know about that is that thing is pi halves minus this reference angle. So the arcsine of the sine of 2 is pi halves minus this little reference angle. So all right, so what is this reference angle? It's 2 minus pi halves. Plug that in here, pi halves minus 2 minus pi halves. And what do we get? We get minus 2, minus is plus pi halves. We get pi minus 2, which kind of makes sense. What that is pi minus 2. So another way to have thought of that would have been directly. But there's my answer.